Should we start or should we wait a minute or so?
I guess you can start.
Okay, then let's start. This is TCPM, TCP maintenance. My name is Michael Trickson. I'm one of 3 co-chairs. The other ones are Yoshi and Michael. And this is the note well. You should have seen it if you attended another meeting. So please read it and do what it says. We already have a note taker, thanks to Gori, who volunteered again. And Michael is a Java scribe, so if you want anything reflected at the mics, I'll put in a prefix mic, and I think Yoshi will do the job in case Michael is presenting. If you are submitting a draft to the IETF and you want that the TCPM working group is aware of it, put TCPM in the name of the ID. That makes it much easier for us to find it and to be aware of it. This is the agenda. A working group status. Then we have a couple of presentations for working group documents. One is on proportional rate reduction, which is from Yu Chung, which is proxied, or who's proxied by me today. Cubic, an update on Yang, 2 presentations on TCP AO, one about the draft and one about an interrupt test. And finally, on the working group documents on TCP, EDO, and EOS, where we have a slide from Joe, and we are also proxying it. After that, we have 3 more presentations, 2 about upcoming BIS documents, and one about an implementation feature provided. The talk is provided by Neil. Anyone wants to bash the agenda? If that's not the case, then this is the status of the documents. We have RFC 793 BIS, and that is after ISJ last call. A revised ID is needed, and Wes is, I think, there and can give us an update.
Yes, the ISG did a really good job reviewing it, and there are a lot of comments. I've worked through some of them, but well, I've looked at all of them. I've actually made edits for a good number of them, but there are a few that I had put off because they involved more research or homework. A good example is there was a question about how we treat source route options, and whether what this document says is totally consistent with what other RFCs, not about TCP, but about IP options, say. And so I wanted to make sure that we did the right thing there and also do something consistent with what real stacks do. So I've been sort of dragging my feet and taking more time to get around to doing the right thing and looking up a lot more information on that one. And there are a couple of other issues like that, but for the most part, the ISG comments are pretty clear, and I think it just needs my attention to get through them.
Okay. Do you have a rough timeline?
No. So I would hope to get around to it really soon, like within the next week or 2, but I've hoped that for a few weeks already.
Okay, so but in case you need help from others, reach out to the mailing list. And
I was going to do that on some of these questions. I think that will be much quicker and lead to better results. So I will do that.
okay. Any questions regarding 793 BIS? If that's not the case, we can go through the list of documents. They are in the order of the milestones, which are often in TCPM not taken that precisely. So we have PRR. I have a status update on that in the first presentation. We have 8312 BIS, where we have also a presentation. HiStart++, Praveen said that he wants to do, so he has implemented what is in the current document, and Microsoft wants to do some more measurements and present that the next IETF, and based on the outcome of the measurements, the document should be in a pretty good shape or not, but that depends on the outcome of the measurements. So that's why we don't see any new information, and we don't see a presentation here. Accurate ECN and generalist ECN are both in the same state as last time, because the LFRS work going on in TSV is not finished yet. We have a presentation on the TCP Yang document in this meeting. We have actually two presentations regarding the TCP AO. Regarding TCP AO, one is about the document describing tests, and one is about an interrupt test. And finally, we have a slide from Joe regarding TCP EDO. Any questions regarding the documents? If that's not the case, any additional statement from any of the co-chairs?
Yeah, this is Michael speaking. Can you hear me? This is maybe a good opportunity for a personal announcement. Also, this meeting is most likely my last meeting at the chair desk. So I've decided to offer to step down to open room for the next generation of TCP researchers so that they can gain management experience. That transition will not immediately take place because since I still want to wrap up some work, the most important one is the top one on this list here. But once 793 BIS has passed ISG evaluation and maybe some other things are done, then I'll step down. And as I said, I'll open room for somebody else to gain management experience. I will still stay around, so I will still continue to work in TCPM, but not on the chair desk. So this might also be an opportunity for Wes to speed up the work on 793 BIS, because this is actually a showstopper. So thanks.
Yeah, thank you. And thank you for all the work you did for TCPM. And I hope we will still have you in the working group as a contributor and reviewer, and a person who can share his knowledge about TCP. Thank you. Okay. The first presentation should be Let me see. So this is regarding proportional rate reduction. The draft is, I think, not active anymore. We contacted the authors, and basically they are pretty busy with other things, but they stated that they will provide a new version in the time scale of the next IETF. And this is the list of changes they currently have in mind, which need to be addressed before the next version, which is 2 bug fixes and some clarifications, especially interactions between PRR and RAG, because at the point of time where PRR was written, RAG didn't exist. So there are some adoptions also based on newer developments on the documents. Are there any comments? Are there any additional things the authors should address? So they said they will read the notes and any feedback will be addressed. Yoshi?
Hello. I just curious about the implementation status of this one. It is already mainline in the kernel or not? Because I see the BIS version is slightly different from original version. So there are some logic updates. So I just would like to know the status of this implementation.
I'm not sure if any of the draft authors are on the call, but I'm in close communication with them, and the believe the BIS is going to basically reflect the latest Linux TCP PRR. There have been a number of minor changes and fixes, I guess changes really, not fixes, over the years, and we wanted to update the document to reflect the experience in the Linux TCP stack. So it will cover logic that's implemented in Linux TCP.
Richard?
So I just wanted to add on this that I've provided some of the feedback based on my experience of PRR in the FreeBSD stack. So this has not yet been fully committed, especially the one that is running without selective acknowledgement. But I believe comments were or will be addressed in an upcoming revision, hopefully.
But you provided the comments to the authors already.
That is correct, yes.
Okay, so the authors are aware of it.
Yeah.
Any other comments? Okay, if that's not the case, then I would say the next focus is Cubic, and Vidi is up. You can run the slides on your own. They have been uploaded.
Am I audible?
Yes, you are audible.
Thank you. So I actually forgot how to do the slides thing.
On the below your name, you have next to the hand icon, there is a document icon, and if you click on that,
yep. Okay,
you should see a list of documents, and you can select your.
So do you see the slides or?
Not yet. I think you have to select it and then.
I selected it, but it just opens on another tab. Hold on. So yeah, I am not sure how to share this with you guys.
Okay, then I can do that.
It's okay if you want to take over. I will let you know. Yeah, thank you very much. I'm sorry I couldn't make it
No
work.
problem.
Okay, thank you. Hi everyone. So in the past year, we have been making some updates to Cubic, and we are trying to adapt it to based on the recent deployment experience in TCP and quick stacks. And a lot of folks have contributed to this effort, and we're really grateful for that. Next slide, please. So I think around 2 months ago, when the chairs were concluding the work group last call, we received a final review from Marku, and this was quite an extensive review. And I'm really glad that it raised some profound issues that we probably missed. So big thanks to Marku and everyone who has helped with writing PRs or providing solutions and all the discussion that is happening on GitHub. So I can cover these issues briefly, just so that everyone's aware what's changing in Cubic Biz. The first one is because Cubic is more aggressive than Reno, so we have mentioned that in the changes we have added that Cubic basically updates RFC 5681, and this is because of the beta factor, which is 0.7 instead of 0.5. Next point is about when we have a slow start overshoot, Cubic only reduces congestion window to 70% instead of 50% in case of Reno, and this means that Cubic's window is 40% higher than Reno. So this could cause high packet loss during recovery, could take multiple rounds. And so we have recommended the implementations or implementers to implement HighStart++ with their Cubic implementations. And that's the experience that we have from the deployment, as most of the implementations are ready to do that. And as I was saying, it could take Cubic more than one recovery cycle to compensate for the 2 times overshoot in the slow start. We are advising the implementers to evaluate their choice of the first multiplicative decrease after whether they receive a packet loss or they receive a ECE-ACK. So this is something they should be evaluating, and we have mentioned that specifically in the draft. The next bullet is about using PRR to reduce the sending rate slowly, during loss recovery. And as Marco pointed out, the draft, when he reviewed it, it incorrectly mentioned employing a fast recovery for all congestion events. So this should only be done for packet loss and not for ECN related congestion events. And now we have updated that. Last point on the slide. Similar to Reno, the performance of Cubic, as a loss-based congestion control, it does suffer in wireless networks because a packet loss is not necessarily, giving us good signaling of the bottleneck capacity. So we have added some text around that. Next slide, please. These are also some important design changes. So Cubic has lower window reduction, and it also reaches Wmax faster than Reno. So it effectively means that it has a shallower sawteeth than Reno. And we have added some guidance regarding buffer bloat and queue management where the new AQMs, the new implementations of AQMs, probably could mitigate some buffer bloat by, for example, setting lower thresholds for the queue size. Next point is very important, and it is about how the draft, how the base draft originally had a lower limit of 2 for congestion window, and there is a crucial distinction between a congestion event due to a packet loss versus due to ECE ACK. I mean, we do need a window of 2 packets in case of packet loss to perform loss recovery, but for ECE markings, we need to keep reducing even beyond a congestion window of 1 by using a retransmit timer that backs off exponentially. So I think this is something that implementations need to be doing. I don't think Linux does this, or other implementations take care of this behavior. This is clearly mentioned in the RFC 3168, and I think we should implement this. So another important point that has been discussed in detail on GitHub is whether to use flight size or congestion window in the reduction equation. The RFC series, the standards RFCs, they all use flight size and not sea wind. But there could be an issue that the flight size sometimes is very low, especially for the rate limited apps when the loss occurs. So the best way to mitigate this issue is to implement RFC 7661. So we have recommended that. And some implementations, for example, Linux currently use CVINT. We have left that as an option as well. Next slide, please. These are some of the editorial changes. There was a bug in the average cubic window equation that Neil had found. Thanks, Neil. So we have fixed that. The next point is about rearranging the algorithms for spurious events detection. We now recommend the standard track forward RTO recovery RFC first, and then we provide some examples or references for experimental RFCs. Then we have added Cubic's response to sudden events like sudden increase or decrease in capacity, and Cubic is more aggressive than Reno in both the cases. Last 3 are some simple editorial changes. Next slide, please. This one is kind of a duplicate of the next one, so we can skip to the next one. Thank you. So this is an open issue that we would like some feedback from the working group. We have some feedback already on the GitHub issue, but if you have not had a chance to look, I can describe this issue. So Marco has raised some objections about the spurious detection and the congestion response to those events. And to provide some context, so there are 2 types of spurious events. At least for TCP, there's spurious RTOs, which is applicable for TCP, and there's spurious retransmits detected by acknowledgements, and that's applicable for both TCP and QUIC. So the first issue is that Cubic is modifying a standards track RFC 4015, which defines a response to spurious RTOs. The RFC 4015, it sets the congestion window to flight size plus minimum of byte sect plus initial window. But in Cubic, we are recommending to restore the congestion window to its previous state before the reduction was applied. So this is the issue. I will come back to the solution in the next slide. Second issue is Cubic is currently specifying a response to both types of spurious events. And Marco said in certain networks, for example, in mobile networks, a path change could increase reordering, and thus it can result in spurious fast retransmit. And at the same time, the bottleneck capacity might get reduced. So if that happens, then restoring to the previous congestion window might not be such a good idea. And that's why he said there is no previous RFC that talks about restoring state due to spurious fast retransmit events. The third one is currently we don't exclude the cases when the ACK detecting spurious event has ECE set on it. So this is a simple one. I think we can fix this one. And the last one is we don't specify, or Cubic doesn't specify any mechanism to adjust RTOs, acknowledgement thresholds, time thresholds, etc., to avoid any future spurious events. Next slide, please. So as I was saying, the first point about violating the standards track RFC is a bit tricky, as the response defined in RFC 4015 is a bit conservative because the congestion window is set to not to the previous value, but to flight size plus a minimum of bytesec plus initial window. Most likely, it will end up to be flight size plus initial window, in my opinion. So this is too low. And I think some folks won't be happy with it. So if you have an opinion about this and how do we proceed or deal with this problem, we'd really like to hear back from you. Second one, spurious fast retransmits. So these are much more common for TCP, and these are the only events for quick. So I think if there is no previous RFC that provides any guidance, perhaps we can record Cubic's response to these events. And again, this is another topic that any input would be any input on this would be appreciated. The third one we can fix in the draft. That's an easy fix. And for the last point, I think a lot of us agreed that we would need a separate draft to cover this, as we want to keep the loss recovery changes separate from the congestion control. Next slide, please. So we will continue to fix any open issues. These are, as next steps. And once whatever issues are open right now are resolved, we will again request the chairs to conclude the work group last call. So if you haven't read the draft, please read it. If you planned to read it, we would like to take care of the issues as soon as possible. Thank you.
Thank you for the presentation and the update. Comments, questions? Stuart.
Hi, Vinny. Good job presenting. I just had a very quick comment about something you said verbally. I don't think it was actually on the slides. You talked about the problems with wireless networks, losing packets. I think actually the bigger problem is not packet loss, because Wi-Fi link layer acknowledgement and retransmission is pretty good. The bigger problem is the huge variability, because Wi-Fi can vary from a gigabit or more to a megabit per second. And that happens if you just walk around the house with your phone, or if someone else walks around and gets between your computer and the access point. So I think the bigger problem, and I don't know whether the draft talks about this, but since you mentioned it, I just wanted to bring it up. The bigger problem is that if your Wi-Fi rate instantly drops from 500 megabits to 50 megabits, when Cubic is only reducing 30% each time, it takes multiple round trips to bring C-wind down by a factor of 10. And of course, during that time, it's sending too fast, the queue is building up, so the round trip time is going up. So the time for the round trip time is going up. So it is true you see lots of loss on wireless, but it's not random packet loss. It is queue overflow because the sender is sending 10 times faster than the link can now carry.
Right. So it's more like a transient congestion loss.
Yep. Thank you.
Yeah. Thank you.
Praveen?
So I have a question. So as we make these changes, right, some of these changes are coming in from review feedback. I'm wondering if some combination of all the diffs from the previous RFC would be representative of a implementation that has implemented all of these changes, or would it be sort of a mix and match? So my worry is that as we make these changes, we might not have had implementation experience of the entire new RFC. So that's just one concern I had. So any comments on that?
It's a great point, and the changes that have been made, before this review were mainly to reflect what the implementations are doing today. With this new review, it's being a little more careful. I would say a little bit conservative in the sense. But we have left the options open with respect to the things that implementations are doing today. So it's not like we're completely closed those gates. For example, using CWIN instead of flight size, using flight size instead of CWIN, that's one of the things. But we have still left options for implementations, which is like using RFC 7661. And if you're not using that, some implementations are still using CWIN and not flight size. So it's not like we have completely changed what implementations are doing. The only change that I can remember which implementations are not doing is the ECN change. And I think that's a good change because ECN CE markings are representative of congestion directly, and we should keep backing off. So yeah, so I would say we're not going too far away, too way off from what implementations are doing. So it should be okay.
A quick follow-up. So this is no longer representative of say the Linux TCP implementation as such, right? It's more of a representation of all the different implementations. Is that the current stance?
Sure. Yeah, we can say that.
Okay, thank you.
Just had a couple quick comments. Oh, one, I wanted to encourage the draft authors to keep the discussion of the undo logic in the draft. I know there was some discussion about whether to keep it or not, but I wanted to emphasize that undoing loss recovery events is really important for performance in practice in the real world. And the cubic algorithm has enough state variables that it's non-trivial to know exactly what variables are need to be reverted, or to be at least reminded that there are many different state variables and not just CWIN and SS thresh to undo. So I think that's important to keep in. There was also in some of the GitHub threads some question of whether it's okay to undo loss recovery if there's been reordering due to a path change. And I tried to respond in the thread, but wanted to emphasize again that I would argue strongly that it's okay to go ahead and undo if you detect that there was reordering and the spurious retransmit, because if there was actual packet loss in that round, then the loss detection machinery will detect that there was also loss and will then invoke the congestion control response and slow down appropriately. So I think that's fine to undo in that kind of scenario that was raised. And also just to echo Stuart on the question of loss in wireless networks, I definitely agree from all the packet traces I've seen from YouTube and Google.com that cellular and Wi-Fi links these days do a really great job of link layer retransmissions. And so any losses that are there are usually because of the kind of scenario that Stuart mentioned, where there's a rate reduction and it takes a couple rounds for cubic or whatever to slow down to match the new delivery rate. So thank you for all your nice work on this draft.
Thank you, Neil.
Lars.
Yeah, some of the things that Vidi talked about, especially towards the end, right? Sort of, and also that Praveen mentioned. Sort of, there's this document started out. I mean, the pre-BIS version started out with wanting to document what Linux is doing specifically, because that was the canonical implementation. And the BIS version started out by wanting to update that because the Linux had changed. And also to roll in some of the things that other implementations of Cubic had in the meantime done. So that is where we started out all the way pretty much until we got Marco's review, which, as Vidi said, right, raised some very conservative points that basically said, you can't move this to the standards track saying this because it's in conflict with, for example, 5618 or 5681 or 4015. And while that's technically true, right? We shouldn't publish a proposed standard that goes against the must in the draft standard. In reality, right, all the stacks have been doing it for over a decade, and the internet is fine. And so at some point, I think we should sort of give up this very dogmatic view on congestion control and try to accept that things have moved on since we published some of those RFCs. So some of those changes we made was because we couldn't come to consensus on the issues on that, but I would sort of really hope that we could be pragmatic and actually, document what is working in practice rather than, find ourselves in a situation where we're unable to move forward because of a must that was written 15 years ago. Thank you.
Ian?
Yeah, I think I want to echo kind of Lars' point, but kind of go in a slightly different direction with it, which is I think we should really be conscientious. I mean, I think all the changes that have been discussed sound mostly sensible, although the flight size C1 change is a little concerning to me because in practice, I think, I don't know. I think that's hard to make right, but maybe it is okay with enough caveats. But I think we should be really conscientious of not trying to put things in a document that no one has implemented. And so if we're in a position where, we get to working group last call and there's some recommendations or even musts particularly, but even some recommendations in there that zero cubic implementations actually do, I think we need to remove them. I think we need to be really conscious of not putting things in the document that no one implements in production. I don't mean a toy implementation, but I mean a major deployed operating system or other environment. I don't know. I mean, maybe I'm too harsh on this, but if no one implements it, there's probably a reason, and putting it in a spec is sort of silly in my opinion. But that's it.
Yeah, one point regarding that. So regarding the implementation point. So if I would make a difference between what major implementations explicitly say that they don't want to do, compared to they might want to do it or they will do it but just haven't done it because it now comes up and it might make sense and they just haven't implemented it yet. So that might be a difference.
Well, that point I'll take it, but the flight size and C1 issue, it really boiled down to, there's no RFC that uses that, and we are moving to standards track, so we have to, I don't know, follow the trend. And I was a bit disappointed with that. Really, there is no point of using flight size, if at all. RFC 7661 is probably the way to go, and that could be a must. I am not very familiar with all the RFC procedures, but that point was really no standards track RFC has recommended it. Why is Cubic doing it?
Yeah. Sorry, I didn't mean to latch onto that one in particular. Just I only said it because I'm most familiar with kind of the ways that can not work. But I think I'm receptive to the idea that if they intend to implement it, that might be okay. But I'm also apprehensive because the IETF has standardized a bunch of stuff that no one implements, and my experience is it usually works out pretty poorly if you have no experimental data, because sometimes it turns out these mechanisms have gotchas that just don't cause them not to work for like detail-oriented reasons that like you just don't anticipate. You know, and this is just the nature of the beast. Like if you've never written code for it and no one's ever deployed it in production, I mean, it probably works, but like you just don't know, and simulations don't really cut it. So I don't know. I mean, maybe I'm fine to drop this issue, but I just kind of want to put my 2 cents in on that point.
Lars?
Yeah, so as a little preview to the talk later on updating 5681, so one of the questions I'm actually raising is if we should try and roll in some of those changes, specifically the flight size versus Seawind discussion we've had because of Cubic. At the moment, the Cubic draft updates 5681 because it wants to make it okay for Cubic to do this, which raises the slightly sort of interesting question whether a proposed standard can update a draft standard. But we might be able to sidestep that issue if we decide to update 5681.
Any other comments? I have a final question for the author. So you are using Hardstart++ as a normative reference?
I think it's Lars, could you answer that one?
Yeah, it is a normative reference because we wanted to use 2119 language to say should. So we are basically tying ourselves to Hardstart++.
So this means, as a message to Praveen, the document needs to progress.
Yes, well, it doesn't need to progress.
Well, the milestones are okay, but and I'm fine with him saying they want to do measurements, he should be aware that there are dependencies.
Yeah, I mean, this is yet another one of those things, right? Where so Hardstart++ is the only standard strike document we have in this space, and since we can't, there's also one of the points that Marco raised, right? He said that we shouldn't recommend something that isn't standard strike in a standard strike document. And Hardstart++ is the only thing that we intend to publish on standard strike, right? So either we say, do whatever or do something very conservative. We might want to, do that. But it's again one of these things where in reality people do things, but we can't say that in the document because of stupid standards reasons.
I just wanted to. So I'm happy if Hardstart++ matches around the next IETF. I don't think it's a problem, but it shouldn't move over and over again.
Yeah.
Or if it does, we have to deal with it in Cubic. Gori?
Michael, can we just be clear for the notes whether the reference to Hardstart is a should or a must? Do the authors just want to say so we can put it in the notes?
It's a should.
Praveen? Praveen, do you want to say something? You were on the queue and just left the queue?
Can you hear me?
Yes, we can.
Hi, I was just responding to your question, so I did mention in the chat as well. So we were just waiting for other implementers to also implement the changes in the latest draft because the latest draft did have a significant change, right? So that's the only reason. That's one of the main reasons we wanted to wait a bit before we go into working group last call. But yeah, I think pretty soon we should be able to get there and then aim to have published this sometime around next IETF.
Perfect. Thank you. Neil, and I'm closing the queue after Neil.
It sounds good. Praveen, could you clarify which other stacks are implementing Hardstart++ and you're waiting for feedback on?
Yeah, so the Cloudflare Quick Stack implements it. I think Apple was experimenting with it, and FreeBSD as well. I think Netflix was experimenting with it. So there's multiple implementations out there. I'm just waiting for more feedback to move forward.
Okay. So Martin states that he's a bit concerned about the proposed working group last call changes don't actually have consensus. So we will, once we see the final document, I think we will ask the working group if the working group is fine with these changes. Anything else?
Sounds good.
Then I think we move on to the next presentation, TCP Yang model. I think it's Michael.
Yeah, this is Michael speaking from the floor. I guess you can hear me, right? Okay. So this is a short update on the TCP Yang module, that is joint work with Mahesh and Vishal. And there have been some recent updates to this document, mostly to ensure that we get closer to a working group last call to finish this small piece of work. So there have been two updates recently. The first one was basically some open issues that were left in there. So we have emphasized now in a much better way and more prominently that the document explicitly has a very narrow scope. So this is the consensus in TCPM that the document has a very narrow scope. We have also expanded on the specific Yang semantics on the TCP connection table, which is writable. So this has caused some discussions in the past. So we added text on that. And there were some open issues in the security considerations, which got fixed. The O3 document was probably the first complete version of the document. And on that version, we then got two extensive sets of review comments, both from Tom Petch. The first email were relatively small, minor edits, which have been fixed in 04. So we've changed the reference for TCP to 793 bis under the assumption that this document moves forward soonish. And then there were some actually bugs in the Yang module, which we have fixed. So this is basically the current version 04. And then we basically received the second set of extensive review comments, actually, which are summarized on slide number 4. So these are a lot of good and valid comments. Most of them are relatively straightforward. So I don't think there's much discussion needed on it. We just have to implement the changes. So I've listed here that there are probably missing references, and some of the references need to be more prominently referenced in the Yang module, and a couple of other things. So as I said, the references need to improve. There are also some small changes in the Yang module that need to improve. Some is just Yang semantics. A more editorial aspect is that the suggestion is to add more warning signs regarding MD5. So that this is a legacy technology, and TCP/AO is much better than that. So we have such warning signs already in the document, but we could do so more prominently, and that's something that's easy to change. And the examples are also not perfect. So these are all relatively minor things that will be fixed in the next version 05, hopefully within the next few weeks. There are only two other things that are the bigger questions, actually. The first issue is that there is an ongoing evaluation in the Ops area working group on a couple of documents actually that work on service models. And one of these models, specifically the L3 network model, also includes Yang statements on TCP/AO parameters, simply because the layer 3 VPN side may need to implement TCP/AO to protect the control plane signaling, as a BGP specifically. And that creates an overlap between those two Yang modules. That is nothing specific to this Yang module. The same overlap happens between the L3M model and a lot of other IETF models, simply because it uses a lot of other technologies. But the overlap with the TCP/M Yang module was not well mentioned in our draft so far. And this is why we have to do something about that. There's also a technical difference in the modeling assumption. The L3NM model assumes that some of the TCP/AO parameters are modeled in the key chain. The only issue is that the corresponding RFC, which is 8177, doesn't foresee that as of today. So that is why we actually don't have that solution as of today. And in the TCP/M Yang model, we therefore have explicitly added configuration parameters for the send ID and the receive ID. We will see later why these parameters are so relevant for TCP/AO. So this is a difference. At the moment, my suggestion is to clearly explain that difference and also reason why this model models those two parameters explicitly. And of course, this also implies that we have to add a reference to the L3NM document, which is still missing in 04. So this is the first possibly a little bit bigger change that requires additional text at least. The last bigger request for change was a comprehensive comparison with the TCP MIP. So we got past feedback in TCPM that the TCP MIP is not so interesting for this Yang module, but now we have a request to make a comparison. So this is something that's not super hard because we still model a lot what is in the TCP MIP already with some slight differences to be future-proof. So we could add such a comparison, for example, in a new appendix. So it's something that's doable, but we haven't done so in the past. So this is something where I would also look for feedback from the community if this is something considered useful. As I said, there have been past statements on the mic on the TCP MIP. So as I said, most of these things are straightforward. We will come up with a new version of 05 soonish. For the last two ones, any comments from the group would be particularly appreciated. And that's the current status. So as I said, there's a new version coming up that should address hopefully all known issues. And we would really look for further comments from the group. As we have addressed all known issues, the authors believe that the document would be ready for working group last call. But of course, that requires feedback from the community. And that's my summary for today.
Comments, questions? Martin.
Hi, Michael. So what is the reasoning behind wanting to, like, why did the commenter want to do the bib comparison?
I mean, it was just, I mean, I guess the underlying assumption is that there are quite a bit of implementations out there of the TCP MIP. So we know that there are implementations of the MIP, and if somebody who implements the MIP wants to transition to this Yang module, of course, maybe a translation table could help. in most cases, to be honest, it's relatively easy to see the mapping. The statistics are very similar. We have removed, I think, one or two aspects from the MIP. We could reason why we've removed that. Also, there was in the MIP there is a setting for the TCP retransmission calculation timeout. So we've removed that one. I doubt that this one is widely implemented actually. So as I said, it would maybe help implementers, but the big question is if somebody who works on Yang in his day job really needs a summary in the document.
Okay. Well, I mean, if you think it's not a lot of work, I certainly wouldn't object to like an appendix, but I'm a little skeptical that Yang is going to become a dominant configuration mode for like TCP endpoints, barring the special case which you correctly targeted, which is like these BGP hosts. So I don't think it's important, but if you don't think it's a lot of effort, I think it's fine. Thanks.
Yeah, I mean that comment is not the first time. So we all know that Yang will not be the most important configuration method for a lot of TCP stacks, but it matters on routers. You also see that in the L3NM model, which also targets routers. So in that specific target area, the model matters, and that's also probably one of the key areas where the TCP map actually is implemented. So at the end of the day, we all know that on host operating systems, this model will most likely not be widely used.
Thank you. Any more comments? So guys, we are looking forward to see the updated document. We'll progress then from there. Okay, thank you. The next is a presentation about test vector, the status of the draft. Mahati, or I don't know how the name is pronounced, this up. Is he there? Yeah.
Hello, can you hear me?
Hello. Yep. You can run your slides by your own.
Yeah, sure. Just a moment. Okay, can you see the slides? I guess you can see the slides, right? Okay, great, excellent. Sorry, I had some technical difficulties. My laptop just crashed, so I had to change to the spare one, but there we go. My name is Juha-Matti Kuusaari, so I'm presenting the TCP/AO test vectors draft and the updates to it. We have been doing that with Joe Touch. So let's see the next slide. So the reasoning here is that implementing TCP/AO is quite complex, so the test vector should help to implement it correctly. And of course, for interoperability, it needs to be correct, otherwise it won't work at all. So here we have provided test vectors for the mandatory options for IPv4, IPv6, or the mandatory algorithms, and for both ignoring and including TCP options. And it also discusses some of the implementation issues that may be tricky for the implementer. This was presented last time, IETF 110. Not many changes. Shortly after IETF 110, we were able to test it in our lab with IPv6, so no changes there. Everything was working fine. Then we got good comments from Michael Scharf. Thanks for those. And the version 02 draft was updated based on them. So there's some clarifications. The NAT traversal was changed to middle box traversal, and also clarified some parameters that which one were decimal or hexadecimal, or even binary for the DCSP fields. So these are the changes. So thanks for the feedback so far, and of course the feedback is always welcome. We as authors think that it's ready for the working group last call. We have been waiting for feedback some time. I guess, I hope it is looking good, so not more feedback, but of course, if something is noticed, let us know. Thank you.
Thank you for the presentation. Are there any comments? Joshi?
So I'd like to mention that Chair's thinking that this draft is in good shape and it's getting close. So if you have any concern or want to comment, you should speak up here or send a message on the mailing list very soon. Otherwise, we are thinking about proceeding the draft.
Yeah, so this is Michael speaking. Also, just as a heads up, this is an informational document. So of the bar for informational documents is maybe a bit lower than standards track. So for an informational document, I think that the working group last call is easier to achieve, and we might not be far away from that.
Any comments? If that's not the case, then we move on to Greg, who is presenting on a TCP/AO interop. Greg, you can run your slides by yourself. Oh, wait a minute. Yep, now it should be possible.
Okay, hey, how's the audio?
Yeah, pretty good.
Okay, hi, my name is Greg Hankins. I'm presenting on behalf of me and also Melchior Ailmans, who participated and helped facilitate this interop test. I should mention it's not clear from these slides. The main use case that we're looking at in the operator community is for BGP, so this test focuses around TCP/AO with BGP and all the work that we're doing to evangelize the technology and promote it in the operator community is around use for BGP as a replacement for MD5. We conducted an interop test last summer. It was in the middle of the COVID pandemic and the shutdowns, so we figured let's use the time to do some interop testing over the internet. It was done remotely using virtual machines, and it turns out it doesn't really matter where they're located as long as there's a TCP connection. So we used multi-hop BGP and established V4 and V6 sessions over the internet. This saved us some time in getting together in person and lugging routers around and things like that. So it's really easy just to spin up a VM and do testing over the internet. We tested with two algorithms there, SHA-96 and AES CMAC 96. The interrupt was pretty easy, but we did learn a couple significant lessons that are here in the slides. Lesson number 1, and this is maybe was not obvious to me as a newcomer to TCP/AO. I think for someone that's configuring it for the first time, it could be a little bit of a learning curve. So the first lesson that we learned is that send and receive are configured from the router's perspective. So my initial configuration was to match the send and receive IDs. It turns out you actually have to have them so that they're opposite, so that the send is configured to the receive and the corresponding receive is configured to the send. That was one important thing that we've learned. We provided this feedback to the Yang model to hopefully clarify that in the Yang model. And we also updated our respective documentation to make sure that people understand that's how you configure it. And the other thing is that since TCP/AO supports multiple authentication algorithms, then or cryptographic algorithms, I mean, then you have to make sure that you also configure the same algorithm, or else it's not going to work. The other lesson that we learned is that we had a firewall in the path, which we initially did not know about. So the Nokia router was connected to the internet and was open. The Juniper router was behind a firewall. And it turns out that the firewall was actually modifying the MSS option for some reason. So this caused the calculation to fail on the receiver, and the BGP session did not come up. So this is actually great because this actually means that TCP/AO was working. Since the packet was modified, the session did not come up. So once we figured out that there was indeed a firewall, we had to do some packet traces on each end, and then we figured out what was going on relatively quickly. The firewall issue was resolved, and interrupt test was successful. There wasn't really much else to say, really. Once the TCP sessions came up, we exchanged routes, and just as an extended test, and everything worked great. So in terms of implementations, there are currently several commercial implementations that we're aware of. If anyone knows of other implementations, please let us know, and we'll add them to the list. There are no open source implementations. This is a problem because the community can't really adopt the technology until there's number 1, open source implementations, and then number 2, a tool ecosystem to support the implementation. So currently there's no open source implementations, and as far as we know, only Wireshark supports TCP/AO. Other tools like TCP dump don't have support for AO yet. So here's the exciting news is that just last week, several members of the community finalized a development project that's funded by the RIPE NCC. We have funding to develop a reference implementation. It's done by Philip Peps, who's been a longtime FreeBSD committer. We're going to provide support by offering router VMs for interop testing. Juniper and Nokia will support the testing with VMs. And the set of deliverables is, first of all, a reference implementation of TCP/AO for the BSD kernel, and also NC Netcat utility, and then a port of that reference implementation to the Linux kernel. We're currently working on more sponsors to also add extensions to some popular routing implementations like OpenBGP, Bird, possibly FRR. And this work is targeted, it's going to, like I said, we just finalized this last week, so the work should be starting relatively soon and release targeted for early next year, hopefully January 22. Oh, that should be January 22, sorry about that. In terms of resources, we have a GitHub page that has the configuration examples that were used for the Juniper and Nokia test. We added some Cisco examples as well. We're also developing a much more comprehensive website, tcpao.net, that is intended to be a one-stop resource for evangelism, resources, why you should use this technology, a central location for links to implementations, configuration, all that kind of thing. Everything that an operator would need in order to figure out if their routing implementations support TCP/AO, how to configure it, and as well as some of the benefits, as I mentioned. And that's about it. Any questions, or if you have any comments or any other tools and resources, or if you'd like to be involved in some of the ongoing projects, then get in touch with us.
Any questions? Neil.
Mention, are the is your team aware of the what looks like a TCP AO implementation underway by Leonard Crestes for Linux?
No, we did not know about that.
Yeah, it does seem like over the past, I guess over the past couple of months, I do see patches from Leonard Crestes for what looks like TCP AO. I think it's underway. It looks like he's revised it a couple of times, but just wanted to mention that.
Okay, I did not know about that. Would you mind sending us a note with the name? I don't recognize the name. I'm not a Linux developer familiar with all of them.
Yeah, I'll send you the
That would
email
really
and then pointers to the patches. Yeah.
Great, thanks a lot.
Michael?
Yeah, I have one question regarding actually the previous the previous talk. Have you looked at the test vector document during that interop?
No, we didn't, primarily just because we each had implementations and we didn't feel like we needed to. And actually, the Nokia implementation was released many years ago, and the Cisco as well, even before the test vectors draft was even written. So that wasn't useful for us at the time, but I expect it will be useful for the ongoing work in the FreeBSD reference implementation.
Yeah, if there's any, if such an observation already can be posted somewhere, for example, on a list, this would be excellent. So if for example, somebody confirms that the test vector document first is correct and second has been useful, so this would be a very strong help for TCPM to finish the document, actually.
Yep.
Thanks.
Was there someone in the queue before me? I just wanted to, I mean, I pretty much like the idea of supporting open source implementations. Regarding the FreeBSD one, do you know if Philip is going to implement this for the base TCP stack or also for alternative TCP stacks like for REC or so?
I'm not sure. That's a good question. I can ask Philip, and we can note that in the project proposal.
Okay. Because I think the base stack supports the MD5 stuff, and the extensions don't right now. Okay. Any other comments? If that's not the case, then thank you very much for the
Great, thank you.
For the interesting information. And the next is neither Wes nor Joe. But Wes is Wes still there?
No idea what's in these charts.
Yeah, so my point is there are two documents, so maybe you can jump in. There are two documents. One is describing how to extend the option space for packets after the initial exchange with SYN segments, and another one which is an individual submission about extending the option space for packets with a SYN option set. So he has made no progress on the implementation, and things that the document is becoming more stable. So the TCP EDO document, he thinks, is ready for working group last call. And the other one, which is an individual document, there are some TBDs, but he thinks it's near ready for working group last call. So that's the status update. Are there any comments, any messages for Wes or Joe?
A little bit. That is indeed quite stable and has been for a while. It's just been a case of there's a lack of eagerness or urgency in implementing it anywhere. And so that's what has been paused on. However, it's not really been changing at all. And there are no known issues that I'm aware of either, other than not really being implemented.
Yoshi.
Okay, so yeah, I think I have a couple of comment EDO, but I will send on the list later because I need to think about it a little bit more. But other than that, I think I'm a little curious about some middle box interaction or hardware optimization interaction of the EDO, and then especially if someone implementing Linux or other OS stack, then I would like to get some feedback if this is feasible or if there is no concerns about it. So I just my concern is this is little less feedback on this document. So, but this is kind of important document because option space extension is very important. So I just would like to see more feedback. And then, and also scene extension. I have some one correction. This is not this is not adapted working group item. So there is no working group Rustco, and so it's not ready for working group Rustco, I think. And then I basically oppose the idea that submitting this draft as an individual submission, individual streams. So if this document, going to publish, it should be adapted working group item and then standardize it. That's one thing I want to mention. That. But this is as my individual comment. Again, I also want to see more feedback on this one as well.
Yeah, the milestones are a bit in the future. Martin, as an individual or as an AD, I don't know.
Oh, as an individual. Thanks for the presentation, Wes. Can you talk a little more about implementation? So are there literally no implementations, or it's just a matter that hasn't been deployed anywhere?
Actually, I believe there was some work, but it was several years ago. I think Joe was working with a grad student who did some implementation work on EDO. I don't think the other one was implemented yet, but yeah, I think there was some work, and that experience was plowed back into the draft. However, it's not the case that that work resulted in like patches to the Linux kernel that are deployed or anything like that. So I think an interesting way to deal with this might be to attempt a last call and see who responds. I think that might force people to look at it, because there's really no driving need for this at the moment, although there had been many times in the past when people wanted more option space and didn't have it. And because of that, that's why these drafts exist. It's only a matter of time before someone comes up again and wants more option space.
Yeah, I mean, I think last call as a technique to like shake out stuff is good, as long as you're willing to accept no as an answer. I guess my other thing would be, I I'm a little uncomfortable with the idea of EDO being standards track. It seems to me like the whole game here is deployment experience with the whole question here is the middle box reactions, and without any deployment experience, I don't know how we could possibly recommend this to people. Experimental would be fine, but standards track seems really aggressive to me personally as an individual. Thanks.
Michael? And I close the queue after Michael.
Yeah, just like to echo what Wes said. 10 years ago, this was really an urgent problem that showed up once per year. And this was basically when we started that work. Of course, things got more silent on options recently, but as I said, there was a strong need for that document a couple of years ago. Of course, the situation has changed a bit, but we don't know the future. So I think it is valid to document some of these things in one way or another. And that's an individual contributor.
Okay. But Yoshi said he had comments, so I suggest that he sends the comments and they can get incorporated in the document. Okay, so we have 40 minutes left, and we need 40 minutes for the next 3 presentations. So I'm running the timer to keep the time budgets reflected. So Lars, you're up next.
Yeah, thanks. Can you share? Should I share?
I would say you share. You should be able to do that.
Okay. I requested to share.
Yep. Yep. Now you should be able to do that.
I think it's these ones. Can you see?
Yes.
And sorry for being so super late with them. I actually didn't have them until earlier today because I thought I would speak without slides, and then I decided maybe giving people something to look at other than myself is a nice thing to do. Right. So,
yeah, but you used a way to submit them, which I don't know how to do that. Maybe it's just.
So you can now upload slides directly to the data tracker as a participant.
Ah, okay.
Which is what I did because I wanted to try it out. But it's a new functionality that needs to be advertised a bit more. But it means that you shares don't have to do all the slide handling yourself anymore, which is nice.
Yep.
Anyway, so it was. I guess it's good I made slides just for that reason. Right. So this is a sort of initial presentation on wanting to raise the question whether we should revise RFC 5681, which is TCP congestion control, which is a pretty core RFC. And I already talked earlier when we had the Cubic presentation on some of the reasons why I think we might want to do that. But let's go ahead. As a brief history, right, so 5681 is the current draft standard. It obsoleted 2581, which was a proposed standard, which in turn obsoleted 2001, which was also a proposed standard. And just based on the RFC number alone, you can see it's been a while since this was last touched. So the main goal here would be to move this to an internet standard, since it isn't already, and it kind of feels like TCP congestion control is sort of ready for that. There's one existing errata which has also been verified on 5681. So the minimum goal would be to roll that into the revision, which is, I think, pretty uncontroversial given that it's already verified. I reached out to the original authors, and Rem Paxton has said that he has moved on and has no time to spend on this, but wishes us luck. Mark Allman and Ethan Blanton said they would contribute, and I've also sort of reached out to Rudy Goel, Neil Cardwell, and Jana Yengar for help, and that is already 5. So if those 5 want to do it, full speed ahead to them. Otherwise, I can sort of volunteer to act as editor, but I felt like I wanted to have some people on board that know this stuff better than me. There's a repository on GitHub which basically has a markdown version of the text that was 5681, and there's sort of just formatting changes and some very minor things related to that, like updating the reference and so on. So the one question I want to raise is, should TCPM even do this, right? Basically reopen 5681 with those goals on the slide. And there's another goal on the next slide that might make that discussion a little bit more interesting, right? And that is, there's things that have accumulated since we published 5681. Specifically, they're widely deployed for a decade or longer, that are in conflict with what 5681 says. And one specific example came up when we did Cubic, the Cubic BIS, right? 5681 says you set SS thresh based on flight size. And Cubic, as far as I know, Cubic basically since its inception and also all major Cubic implementations don't do that. And they update SS thresh based on sea wind and not flight size, because it has benefits in app limited scenarios, which is technically not allowed by 5681, right? Which is why it was raised for Cubic when we wanted to move it to the standards track. Gori pointed out there's RFC 7661, which is experimental, that already sort of allows SS thresh to be set to something between flight size and sea wind. So Cubic would be sort of in line with 7661, but 7661 didn't update 5681, and it couldn't because it's experimental, right? Also, Quick, I think this was brought up by Yushin, the Quick congestion control document actually defines updating SS thresh based on sea wind, and so is also not in line with 5681. And we have sort of, this is one example of something where, you know, we are sort of diverging from the original specification in 5681, but there's probably others like that, and others might have other examples. So the question is, if we did update 5681, did we want to move some of these things in? Specifically, for this one, the Cubic BIS document that we're doing is already updating or proposing to update 5681 specifically to make Cubic's behavior okay. Basically saying, you know, whatever Cubic does is fine too. And there might be other things here that we might want to sort of make okay based on 5681. This does raise the question sort of in terms of sort of the standards process, you know, if we move things into 5681 that aren't baked enough, you know, would that mean we need to go back to proposed standard with it, or stay at draft standard and not go to full internet standard? But I think that question of how we're going to do this, we can answer once we know what we want to do to the specification. And I see I have people in the queue, which is good because that's all I had. Thank you.
Maya.
Yeah, hello everybody. Thanks for bringing this up. So I think actually these changes on this slide are more important than moving to internet standard. So I think we should do a BIS for having these changes. If we go for internet standard afterwards or not, it's a different question for me. We might still be able to do it because it's based on what's actually implemented out there, but that's the less important point for me. And I also want to mention another thing. I think Gori started some document to try to define something like TCP fairness or whatever. Maybe that belongs into the same bucket. Not sure.
Martin.
So as an individual, I support this work. I am someone inclined to just roll in the ABC BIS into 3465 as well, but I know that's the next talk, so I'll just leave it at that. But regarding like the standards level, I don't have a really strong opinion about it, but I do think we need to think hard about like maybe reframing the language to be a little more permissive in terms of experiment and so on. If the internet standard, like it's going to be very, very hard for documents to modify it. And so like I would love to reposition it to say, you know, to talk about congestion control experiments, to explicitly acknowledge the existence of things that we know about, like Cubic, which I think you're doing here, and you know, just I just don't want to have like further tinkering blocked by, you can't modify, you have a proposed standard and you can't modify this internet standard, and just have that be a line of objection to further experimentation. Thanks.
Mia, please be brief. Praveen?
Largely, I support this work. I think this makes sense to me. Same sentiment as others. I'm not yet sure whether it will be an internet standard. Congestion control is still evolving. We're still finding new ways of doing things. So, you know, not baking it in would be a better thing to do. But this makes sense to me. I had one question. So apart from this particular SS thresh issue, what are the other changes that we're thinking about? Are there like other issues or updates that we want to do here?
I don't know, frankly. So I haven't had a chance to sort of get together with the people. I got to the point where I asked them whether they're interested, but I haven't actually sent an email that says, so what do we want to do? I think I basically, when I contacted them, the goal I pitched was to move this to internet standard. And so by definition, we thought this was going to be a pretty minor update. If we think we want to make more changes, then you know, we sort of need to reconfirm and restate this. But I don't know. So I'm guessing we want to sort of maybe start a list of some sort. I'm hoping it will be still a short list. But this is the one thing that I had fresh in my mind because of Cubic.
Gary? You are still muted.
Can't hear you, Gory.
Can you hear me now?
Yes.
Excellent. So it's true. I started something in TSVWG to try and catalogue all the things said in RFCs about what was thought good practice for congestion control. It's a long list, and not all of them we probably now believe in. So where does this really lead us to? I think we can document what New Reno is. I'm a bit frightened that we don't really know the answers to changing it significantly, in other words, rewriting the spec. And I'm particularly wondering about what happened in Quick, because I thought Quick was Reno-based, and that was what the charter said, no congestion control work, and yet we put Cubic's reaction into 9002, which clearly isn't what the RFC series said. If we make things like this happen, how are we going to write a new 5681 that covers everything? I think this is hard, and we should think carefully about what we want to achieve.
Bob?
The links out there are fine. Oh dear, sorry.
Bob, your audio is really poor. You're very garbled.
The changes on this slide are
better.
fine. Moving to internet standard, I think, would be wrong. Can you hear me now? Yep. And then, and the reason is that I think there's reducing use of Reno, so it seems a bit strange to make something understand this away from.
So sorry, Bob, that wasn't really comprehensible.
Since we are running out of time, I would say, Michael, what do you want to say?
Yeah, just have a quick comment from the chair. There's also something that might have editorial changes. 793 bis has a congestion control consideration section, and that changes the framing for 5681 BIS document a bit. So because there are basic congestion control requirements in 793 BIS, and as of today, this was basically 5681. So as I said, the changes in 793 BIS actually could result in editorial changes in this one as well.
Okay, so I would say we get this discussion to the list, since we have to move on. So the next one is about ABC. Vidi, should I run the slides again?
I can try.
You can try. Okay.
Ask to share slides, or?
Well, you can do it if you want. Okay, here we go.
Okay.
And you have 15 minutes, but if you can do it in less time,
I'll do that.
It's better.
Yeah. Can you see the slides?
Yes.
Oh, nice. So this is a discussion on the mailing list about, how ABC is currently right now, and Yu-Chung, Neil, and I, we talked about it, and probably we want to bring our proposal to this meeting and to the mailing list. So let's see. So recap of RC 3465, appropriate byte counting. There is earlier in, I don't know, I wasn't really working on congestion control in 1999, but there was a paper in 1999, and it was about how, the receivers could manipulate senders and can manipulate the senders to increase the congestion window by sending acknowledgements for 1 byte instead of for the whole packet. And this means that you will increase the congestion window by 1,000 packets, but the receiver could basically be just acting 1,000 bytes. And so the RFC 3465 fixes this by making the increase based on the bytes acknowledged, not per ACK. And the issue that is discussed in RC 3465 is about a stretch stack, which could sharply increase congestion window and cause very bursty behavior. And for that, it has a limit, a cap called L, to limit the bursting behavior. So this is the recap of 3465. On the next slide, we are talking about the problem statement. So with so much evolvement and advancements, the cap of 2 packets is not cutting it. So we think that these days the stretch acts acknowledge a lot more, significantly more packets than 2 packets. And this means that the congestion window increase is going to be limited by 2 packets, and it's going to be very slow. The increase is going to be very slow. Linux and other stacks don't implement this limit because of the low throughput and the low CVIN increase issue. And Linux has been implementing ABC without L since 2013. And it basically the way to control bursting, it encourages to use pacing to reduce the bursts. The solution, we're trying to propose a solution where we remove this limit L, and we say that the increase in the congestion window is a separate problem from bursting. So we use the ACK information, the total amount of bytes acknowledged, to increase the congestion window, and basically that's based on what we are learning about the network and what we are probing. And we will separate out the bursting issue by using some sort of pacing. The RFC, the PRR RFC 6937, it defines a new state called delivered data. It's just basically, the amount of data that has left the network. So we're proposing to use that to increase the congestion window. And In the next slide, I can describe what delivered data, what's the definition of delivered data. So it's in in just plain English, it is the amount of data that has left the network. And let's say if SAC is supported in that case, when we don't have any SAC blocks, then delivered data is basically changing the old UNA and the new UNA. And when SAC is supported, when there are SAC ranges, which means there is some reordering or there's some packets are getting acknowledged before the send UNA is increasing, then the delivered data is changing the UNA and whatever is the delta in the SAC blocks. When SAC is not supported, then first case is when there are no duplicate acts, it's just same as the previous case where it will be changed in the send UNA. And when there is some recovery going on and we have duplicate acts, then delivered data will be equal to 1 packet on every single dupack because 1 packet is leaving the network. And on subsequent partial or full ACK, it will be updated to whatever is the change in the send UNA, and we will subtract 1 SMS for 1 packet for each preceding dupack. So, so that we don't double count the packets that are cumulatively acknowledged in the full ACK. So this is a simple definition of delivered data, and it reflects exactly what is leaving the network at with any ACK. We know how much data has left the network. And this is the last slide. This is a simple change, probably. And can we fold these changes into 5681 bits instead of doing 3465 bits? And that way we can obsolete probably the 3465 ROC. That's all I have. Open for questions.
Martin.
So as I said a minute ago, yeah, I think the answer to the last question is yes. 5681 already has ABC, but with L equals 1, if I characterize it that way. So I think just like having fewer documents would be good. The other caution I would have is to email Mark Allman. As many of you know, I've had like an extended discussion with him about this, and he has some real concerns about just ramping up L in the way that you're talking about here. Granted, it is happening in the internet, and this is an argument we should probably actually have rather than just kind of rubber stamp. Thanks.
Praveen?
I just wanted to point it out that the Windows TCP stack does use L and it caps it to 8 right now. So that change was done particularly as stretch hacking became more common, and Windows TCP stack doesn't do pacing either right now by default. And I believe Linux doesn't do pacing either by default. So my concern with just removing the L limit is that then we should say that pacing is mandatory, right? So that's what the quick RFC ended up doing, right? So the quick congestion control RFC says, I think pacing is a must, if I recall correctly, and then it doesn't have the L limit in the specification, right? So yeah, if we want to remove L, then you have to make pacing mandatory. That may not work for all implementations on IoT devices, etc., where pacing might add overhead. So I think this is a far more nuanced discussion than just saying let's remove L, in my opinion.
Right, you're absolutely right. Without pacing, there needs to. I mean, I'm not in a favor of L, but I think the quick draft does recommend. I don't think it says must. My memory is probably not accurate, but it does provide an alternative, which is kind of pacing in the transport stack by distributing how much you're sending in one send during the whole RTT. Maybe someone can correct me. But you're right. Without pacing, there can be a L, but we couldn't reach a consensus on what this L would be. Like you said, Windows is using 8. I think we are using 10, and the draft says 2. and Mark is going to, based on my, whatever he has replied on the mailing list, he's not going to like, because then that's just, we're just guessing numbers. So perhaps we can also take this to the mailing list.
Yoshi?
I have one clarification question. So in my understanding, ABC is used for slow start phase and then congestion avoidance phase, but ABC is not used to recovery phase, in my understanding. So in the slide, you mentioned about the deep work key, but is this for the other case, not the recovery case? When packet loss happened, I just would like to know, if you want to apply ABC during the recovery phase.
I think if you read the ABC draft, for example, if there's a RTO, then there's a slow start recovery. And in that case, it says it recommends L equals to 2 in certain scenarios, and in other scenarios, it recommends L equals to 1. But for the fast retransmit scenario, you're right, because that would be in congestion. I don't think we use ABC in congestion avoidance at all, because that's straightforward increase by 1 MSS. And that would apply to the loss recovery as well during the fast retransmit, but not during the RTO recovery.
I see.
Yeah.
Ian?
Yeah, I just wanted to confirm that the quick RFC 9002 says either you must pace or you must limit L to 10, basically. And the choice of 10, to go back to the question of whether it's a magic number or not, it's not, I mean, it is short of a magic number, but that magic number comes from the IW10 draft, which kind of implicitly allows you to burst 10 packets into the network at once as a direct result of that draft. And so, if you're going to pick a magic number, you might as well pick one based on an existing RFC. It also matches in it, coincidentally, the initial pacing, the FQ pacing quantum, the initial FQ pacing quantum of Linux. And so there's also experimental evidence for it. That's not to say I actually think 10 is the right number, but it's something we have. So yeah, just those things.
Thanks, Ian, for clarifying. Yeah, I was unsure about it.
Praveen?
I think so we should recommend pacing, I guess, and then fallback should be an L value. And I'm perfectly fine with 10, although we are using 8. 10 seems reasonable to me based on the initial window that all the stacks are using.
Right. The issue raised by Mark was it's not really that you're bursting 10 packets. You're bursting X plus 10, right? And X is whatever window you have right now. So the point is really not whether it's 10 or 2 or whatever. I think the point is it goes beyond what ABC recommends is can you burst the whole congestion window in one send? And I think the pacing is answered. The answer to that is pacing. We cannot. I think we shouldn't be bursting a whole congestion window wherever we are in the slow start phase. So.
Okay, so I closed the line, and let's say we continue the discussion on the mailing list. In principle, I think less documents are better than more. So the rest of the time is Neil. Can be spent by Neil on silent close.
All right, so I'm going to try to share my share.
Well, you can share
slides.
your presentation. The slides have been uploaded. Yeah. So if you click on the upper left document icon,
I clicked on it, and it thinks I've got it. Oh, there it goes. Let me find.
Yeah, we have to approve it. You can request, we approve. You do.
Here we go. All right, can everybody see that?
Yep.
Okay, great.
So we wanted to talk today about an issue that we have seen in production and a particular solution that we've been using and wanted to discuss it with the community. And this is about this feature is called, or we call it TCP silent close. So the motivating scenario here is if you imagine a large-scale internet service where it has TCP connections to millions, perhaps hundreds of millions of cell phones, and then the server machine's kernel TCP stack closes all of those TCP connections quickly due to one of two kinds of situations. Either one, the server application exits or restarts cleanly for updating the executable or updating the configuration, or there is a server application crash, so the process segfaults and dies, and the kernel closes all of those millions of TCP connections. So in either of these cases, the clean exit or a crash, what you have here is you have TCP in the kernel bursting millions of fins to millions of cell phones, often in the local region or country. So obviously that has a problematic impact. In particular, there's heavy network and energy resource usage, basically to find and contact and wake up those millions of dormant cell phone radios. And then there's also significant impact because the cell phone network then has to queue those fins and repeatedly retry them for the phones where the radio is powered off or the phone itself is powered off. So it might be retrying those fins all night in some cases, depending on the cell phone system implementation. And that has the potential to cause cellular networks to become overloaded and in some cases fail. And so the concern here is that this kind of scenario is a potential scalability or reliability vulnerability for some cell phone networks out there. So is this specific to TCP? Well, in TCP, this problem happens in particular because the responsibilities are typically split between the application and the kernel. And here we have a case where the application crashes or exits, and then the kernel still has the state for that socket, and it tries to finish the FIN-ACK handshake at the end, but can do this in a very bursty manner for millions of connections. Interestingly, in a protocol like QUIC that's typically implemented in user space, you probably don't have this problem because the kernel has no transport state. So if the application exits cleanly or crashes, the kernel has no state, so it can't actually do this, burst of 1 million fins or the equivalent. And so there's no extra network load, and so you don't run into this problem. But in general, presumably this problem could happen for any kernel transport. So the goal of the TCP silent close effort was to say that upon application exit or crash, instead of sending this big burst of millions of fins, we want to basically manifest the traditional behavior that the internet has seen for either a kernel crash or a machine crashing or powering off. So basically, in that situation, we have all of the connections from the server that just crashed or died, they go silent. And then any later incoming traffic for those connections that's sent by the client and then arrives at the restored or rebooted or powered on server, then triggers a reset because obviously that server's kernel has no state for that connection. So we still want it to be the case, though, that upon a normal or healthy close of a TCP and of an individual server TCP connection, we want to go ahead and use the traditional FIN-ACK handshake at the end. And one key design feature of this approach is that there's no new network behaviors introduced in this kind of silent close approach, because basically applications and TCP stacks already have to be prepared for this kind of silence and then a reset if they try to later contact a remote endpoint. Obviously before, this could happen with a kernel crash, a machine that's powered off, a cellular or Wi-Fi link that is no longer usable because the user is too far away from an access point. But after, if we have a silent close feature in place, then obviously the same symptoms can be manifested with an application crash or an application exit. So just to clarify what we're talking about here, if we compare a sort of server process exit or crash, before with a traditional TCP implementation, the behavior you would get would be millions of FINs going out to the network in a burst to all these handsets, being retransmitted many times or retried many times. And after, if you have a sort of silent close feature and there's a server process exit or crash, you don't get that storing of FINs. And so what is the precise mechanism that we're proposing here? So the idea is a Boolean TCP silent close per socket option, set via set sockopt, get via get sockopt. And when this feature is enabled and a TCP connection is closed or shut down for any reason, then the kernel sends no FIN, sends no reset, and the kernel frees the socket state immediately. And effectively, as said before, the goal is that upon application exit or crash, the connection manifests the traditional behavior for a kernel crash or machine power off. The connection goes silent. Any later incoming traffic just gets a reset. And in particular, we've used this option for years at our team for a limited set of very large-scale services. And we plan to send this code upstream to Linux when NetNext opens, I believe next week. And so we wanted to discuss this in this community since we wanted to start getting this in the open source world. So the usage model is pretty simple. The idea is you enable silent close on a listener or immediately after a connection is established, after accept. And thus, if the process crashes or exits at any time during the normal operation of that connection, you don't get this large-scale burst of FINs. However, when the process wants to go ahead and close a single TCP connection because the work is done or the client went away, the idea is you sort of disable this silent close feature, and then you do your close or your shutdown so that you get a normal FIN-ACK handshake when everything is going that smoothly and cleanly. The API is very simple: set sockopt, TCP silent close to a value of 1 to enable, 0 to disable, etc. The API details, we would suggest that this is, at least for now, guarded by a sysctl so that the system administrator has to explicitly enable this since it's a new feature. We propose that the child server sockets inherit from the parent so that you don't need a new system call to enable this on every new connection to reduce overhead. We would propose that it overrides the SO linger setting and returns immediately. We looked at some other alternative semantics or considered those. So for example, we could say that perhaps if the application does a close or shutdown system call, perhaps that always attempts the FIN-ACK handshake, and perhaps you only would have a silent close feature upon process exit, either cleanly or due to crash. And we decided that might prevent applications from programmatically deciding to silent close millions of connections if they realize they need to manage memory or handle denial of service attacks, etc. Usage considerations. We do encourage people before deploying this to really consider the possible negative impacts. Obviously, if the server is closing the connection without the FINs, that could leave extra memory usage either in the client side or in the middle box. So we do want people to consider that. So we do want this to be a feature that's used carefully and only to prevent outage prevention, only to prevent outages, not just to save a few packets here and there. And there has been some related work in this area that I think helps motivate this and show that the community does feel like there has been a longstanding need for this kind of thing. So there was a paper from Connext a couple of years ago called a silent TCP connection closure. And their motivating use case was cellular networks as well, although their angle was reducing energy consumption and signal load. That we thought was kind of a heavyweight implementation because it required a new option on the wire. It required so you have to upgrade the client and the server OS, and then you have to upgrade the client and the server application to agree on this, enabling this. So we didn't think that was a good model. There's also SO linger, which has been around for a long time, with a similar motivation, like practical motivation of scalability, avoiding time wait state on servers for millions of connections. We thought this was similar in spirit, but we didn't want to change this sort of long-standing API or add a new magic number to that existing API and risk compatibility issues. There's also an interesting silent close implication of the Linux TCP repair mode, which is for connection migration. But the semantics don't really line up with what you want, because if you use TCP repair mode, you basically are serializing your connection state and disabling the operation of that connection in the kernel, which is not exactly what we want to do here. Here we want to basically be able to continue to use this connection and just say, if that application exits later on, then we want to have that be a silent close for that connection. So yeah, so the effort status, we've used it for years, and we wanted to open source this, so we wanted to discuss with the community. Yeah, we wanted to invite discussion, although I see we're probably out of time, but maybe on the list, people can offer thoughts or now as well. Thank you.
Thank you for the presentation. We are basically out of time, but maybe 3 quick questions, Mia.
And then a question, I will be brief. So as you said on this, where you talk about usage considerations, you basically have a trade-off here, right? You try to reduce network load, but you increase load at the other side and maybe middle boxes by not sending something. So I'm not sure what I think about this idea, because I don't know how to rate this trade-off, right? I don't understand what the implications are for all the involved parties.
Okay, thank you. Yeah, so it's our estimation and experience that the extra load that it's imposing, keep in mind, is just memory in the middle box and in the client, and those pieces of the system already have to have logic in place to do garbage collection and bound that state. So it's our sense that it's a net safety improvement to deploy something like this to avoid accidental, massively excessive load on the cell phone network, since the players that have to do with the extra state already have to deal with this issue of bounding that state.
Okay, so the question I had was, I understand that you do this if you close the socket or the kernel closes the socket because the process died, but if you shut down the read or write side, I'm not sure if you do, if when you do that, the TCP connection should go away.
So I don't think this changes the shutdown of the read side. On the write side, I believe my recollection of how we've implemented it is that if you enable silent close and then you do a shutdown of the write side, I believe it omits the fin and the ACK. I think that's a detail we could, if people see problems with that, we could obviously discuss that
We can discuss
on the list.
this.
Yeah.
Stuart, last comment.
Thank you. I'll try to make this quick as we're over time. I see the arguments for this, and I'm not saying it's a bad idea. I am saying it needs to be done very carefully. I think there's a real risk of unintended consequences here. It's very easy, like in the research paper you cited, they don't send the fin to save packets. And as you say, this puts a bigger memory burden on NATs and firewalls for that state. And that also has a consequence because I'm sure you're aware right now, TCP NAT mappings tend to have a much longer lifetime than UDP mappings. And the reason NAT gateways could do that, and firewalls and other middle boxes, is because they can assume they'll see a TCP fin or reset that tells them when a TCP connection is done. So merely the lack of traffic does not mean a connection has been abandoned. If this socket option is widely available on Linux, that makes it very easy to just abandon connections, then that will force NATs to be much more aggressive about scavenging apparently idle TCP mappings, just like they do for UDP today. And then you might end up having to send 10 times as much keep alive traffic in this future world. So this apparently well-motivated move to save one fin packet has the consequence that we're now sending 10 times as much TP-Lime traffic 24 hours a day to stop these connections typing out.
Yeah, I agree. It's something we have to carefully consider. I guess my sense is that hopefully these NAT boxes are using some sort of LRU map, LRU policy for eviction anyway. So hopefully it would work out in practice, given that given the intended usage model. But yeah, those points are all I'm thinking.
We have the reality today that one of the reasons Quick is not suitable for long-lived, mostly idle connections like push notification connections is because UDP mappings have to be aggressively recycled because there's no explicit fin or reset. And if we effectively move TCP in the direction that it also has no explicit connection termination, we should expect to see the same lifetime for TCP mappings as we currently have for UDP mappings.
Yeah, it's worth considering. Thanks.
Thank you for the discussion. Thank you for attending. I suggest to move the discussion on the mailing list. Would say thank you for attending the meeting. And Michael, Yoshi, you want to say a final word? Or if that's not the case, then I would say goodbye and see you next time, and wherever it is. Bye.
Yeah, thanks a lot for attending TCPM. Bye.